Good morning, stats. We've got ourselves a new chapter here, chapter 3. You're going to notice in chapter 3, there's not as much math and numbers as there is vocabulary and kind of explaining things. This is a very important chapter to develop statistical analysis as we move forward. But right now, this is all going to be about introduction to data collection. So we're going to have a lot of different vocabulary words and a lot of different kind of explaining and interpreting things, not so much the analyzing or creating. So we're going to start off with 3.1. And like I said, it's a lot of definitions. So objective one is to distinguish the statistical questions from other types of questions. So how to complete statistical problem solving process. This is really key. We're going to come back to this a lot throughout this year. So the first thing that we need to do is we've got to be able to ask questions. Okay. Can we clarify the problem and ask valid questions? So you'll see the first objective today is a question statistically valid? And we'll go through that. Then we're going to collect data. We're going to design and carry out an appropriate plan. How are we going to collect that data? We'll do that throughout the rest of the year. We're going to analyze this data using appropriate graphical or numerical methods. And then we're going to interpret the results and draw conclusions. Okay, so a very important note here is a valid statistical question is based on data that varies. We've got to make sure that the data varies. So when we go and ask this, is this a valid question? Does the data vary, or is there only one specific answer? If there's only one specific answer, then that's the answer. There's nothing to distinguish or to analyze. It would just be the answer. Okay, so let's take a look at a couple of questions here on whether or not they are valid statistical questions. So determine if each of the following is a valid statistical question. Justify your answer. How much money does Mr. Tagawa have in his wallet right now at this very moment? Okay, so is this a valid question? And the answer to that is because it's only a one-time thing, we want to know right now that this is not valid. Okay, it's not valid. Okay, this question can be answered with a single value. And it will not vary at all. Okay, so that does not vary. Okay, so how long, part B is how long can students at your school hold your breath? Because we're dealing with students, okay, then this would be a valid question, okay, because it's going to vary. So the answer to this question is based on data that will vary. So therefore, this is a valid question, okay? The length of time that each student at your school can hold his or her breath is the data that varies. So yes, this is. Question C, do most U.S. adults, again, here's the word adults, we're not looking at one, engage in vigorous exercise at least once a week? Okay, so do most, and this is valid. Okay, and again, you're going to kind of, when I ask you if this is valid or not, you're going to kind of have the same response here. The answer to this question is based on data that varies. The answer to this question is based on data that will vary. Okay, and yes, this is a yes or no, but here's where we go back to stuff that we've already learned. Example B would be quantitative data, where we would get a numeric answer for how long they could hold their breath. C is categorical. It's a yes or no, but it's going to vary dependent on how many adults you ask. Okay. So again, does the data vary or not? That's whether or not it is a valid statistical question. All right, let's look at the next objective is to identify the population and sample in a statistical study. So the population is the entire group of individuals we want information about in a statistical study. So every single person. The census would be for us to collect data from every individual in that population to get a census, it's very difficult, okay? Unless you have the entire population of what you're trying to figure out in front of you to answer that question, it is difficult to get an entire census. So therefore, we usually go to a sample or a subset of individuals in the population from which we collect the data. So there is two different types of population that we look at. We look at a sample set or we look at a census. Census includes every single individual. If you don't include every individual, then it's a sample of that population. Okay, so samples of students in SOTA. So identify the population and sample in each of the following settings. Okay, so for example, A, the student government at a high school surveys 100 students at the school to get their opinions about a change to the Bell schedule. So what would the population be? The population would be all the students in the school. Okay, so the populations would be all the students in the school, and the sample would be the 100 students that they surveyed. Okay. Example B says the quality control manager at a bottling company selects 10 cans from the production line every hour to see if the volume of soda is within acceptable limits. So what are we looking at? We're looking at every single can in the production line for every hour. That would be the population. The sample would be the 10 cans that they select. Okay, so the population is all filled cans within the hour. Okay, so every single can that goes through that production line, and the sample set will be the 10 cans inspected. So again, population is the census, and then the sample is whatever part of that census that we are choosing to ask the question or look at the data for. Okay. Objective 3, distinguish between an observational study and an experiment. So again, two more vocabulary words that you've got to make sure you know the difference between an observational study observes individuals and measures variables of interest, but does not attempt to influence the responses. An experiment deliberately imposes some treatment on individuals to measure their response. So note, when the goal is to understand cause and effect, we're going to use experiments. Cause and effect, we're going to use experiments. Is the only source of fully convincing data. In the time and age right now that we're in with COVID, you're noticing that a ton of experiments were done on these vaccines. That's the only way they were able to get them out. They had a study that were given a null dosage that did not have any of the COVID vaccine, and then you had an experiment study that had a group of people that were given the vaccine, and they had to monitor both of those to see the different side effects. So to get our vaccine out, we definitely had to use experiments, and people had to volunteer to get the vaccine to see how it affected them, okay, to get those things approved. So what affects blood pressure and memory? Determine if each of the following study describes an observational study or an experiment. Explain your reasoning. So again, we got to explain here. So take a look at the words that we're going to use. 90 residents of a retirement community were selected at random. Each member of the sample was asked a number of questions, including questions about exercise and blood pressure. Residents who exercised more often were less likely to have blood pressure. So in this problem right here, okay, are we doing anything to lower the blood pressure? And the answer to that is no. We are asking a basic question. All we're doing is asking questions. We're not trying to influence or change the behavior one way or the other. So this is just an observational study. Okay. And then I need to explain my reasoning here. So there were no treatments imposed. No treatments. That is not how you spell treatments. Okay, so there were no treatments imposed on residents of the retirement community. In other words, residents weren't told to exercise a certain number of times per week. So residents were not told they had to exercise a certain number of times per week. Okay, so to make this an experiment, we could have said, hey, group A, you're going to exercise 1 time a week. Group B, you're going to exercise 3 times a week. Group C, you're going to exercise 5 times a week. And group D, you're not going to exercise at all. And then we could compare their blood pressures and come to a conclusion that, oh, it's probably better to exercise 5 times a week because this group had a lower blood pressure than residents that only exercise once or none. Okay, that would be the experimental. So example B here, students in a statistics class were divided into 2 groups at random. Students in one group were given a set of words to memorize in a room with music playing. Students in the other group were given the same list of words to memorize, but in a quiet room. Students in the quiet room were able to remember more words on average. So this right here is experimental. Okay, so this is an experiment. Okay, and then why is this? Treatments were imposed on the students. Okay, what were those treatments? Some students were assigned to memorize the words in a room with music. And the others were assigned to memorize in silence. Okay, so again, this is an experiment because treatments were imposed on the students. What were the 2 treatments? Some students were assigned to memorize the words in a room with music, and the others were assigned to memorize the words in silence. Later on in the year, we'll go through these types of experiments and we'll analyze the data. So that's 3.1. Again, it's a ton of words, a lot of writing. I'm sorry you got to read my chicken scratch, but hopefully these definitions, make a list of these definitions. These are things we have to memorize and learn as we kind of move forward, analyzing the data here and collecting data and then being able to analyze it. All right, you'll have a few problems to do in Edulastic.